everybody, welcome to another video. Hope you're ready to flex those brain muscles. In this video, we're going to talk about the law of sines, and we're going to use it to solve some triangles. So up until this point, you've probably been solving right triangles, where we use our trigonometric functions, right, SOHCAHTOA, and we use Pythagorean theorem to solve these right triangles. But the problem is, what if we're given a non-right triangle? Our trig functions, in terms of SOHCAHTOA, that doesn't work with non-right triangles. Neither does Pythagorean theorem. So we need another way, and the law of sines is one of those ways we can solve non-right triangles. Another way is law of cosines. That'll be my next video, right? So law of sines and law of cosines is generally what we use to solve non-right triangles. They work for right triangles as well, but we just don't use them because it's quicker to use SOHCAHTOA and Pythagorean theorem. So let's go and get into it. The law of sines is basically a formula, and it shows this relationship between the sine of an angle and the side length of the side across from that angle. That equals the sine of any other angle over the side length across from that other angle, right? So when we're using this in practical terms, we only really ever have two. We're comparing two. So either we're comparing A and B, A and C, or B and C. But this is the full law of sines. But like I said, when we're actually using this, we're just comparing two of these. So the idea is we have four values here for comparing two of these. We have four values. We need to know three of them. And then if we know three of them, we can solve for the fourth, right? That's how it works. We can't have two unknowns. It's not going to work out that way. We have to know three of these. So that's where these cases come in. We have case one. We have one side and two angles are known. So this is ASA or SAA. This is the abbreviation. It's angle, side, angle, or side, angle, angle. And angle, side, angle, we go in order. So, for example, if I knew angle B, side C, and angle A, that would be angle, side, angle, right? Side, angle, angle would be something like if I knew side C, angle A, and angle C. Okay, so those are kind of the abbreviations. Again, as far as memorizing this, not really that important. The main thing about this is knowing when and when not to use law of sines. Whether you memorize these cases or these acronyms or not really doesn't matter, in my opinion, as long as you know when to use law of sines and when to not use it. So continuing, case two, two sides and the angle opposite of one of them are known, right? So for example, this will be SSA, and you could also write it as ASS, I guess. Maybe your math teacher has a sense of humor and you can write ass on your exam, but typically we write it as SSA, but either way, I don't really care. Two sides and the angle opposite of one of them. So for example, if we had side C, side B, and angle C, right? Because then we'd have C, B, and angle C. We could solve for angle B and go from there, okay? So when we have one side and two angles, maybe you're thinking, wait a minute. If I have one side and two angles, what if I have this side A, this angle B, and this angle C? Then I'm not able to compare two things. Well, think about it. If we have two angles, we can immediately get that third angle. All three angles have to add up to 180. This is true with all triangles. So that's how you'll do something like that. If you have side A, angle B, angle C, you'll basically do 180 minus B minus C, and whatever's left over will be that angle A. Then you'll have two values you can compare, right? That's the goal of using law of sines, is you always want to compare two things. So typically you'll be given some kind of ratio that you know, or you'll immediately be able to find it by subtracting from 180. But we'll go ahead and get into some examples, and hopefully this will be more clear. And by the way, this case two, this is the tricky case, right? This is the trickiest part of law of sines and law of cosines and just solving triangles in general, because this is the case where we could potentially have no triangles, one triangle, or two triangles, right? The ambiguous case is this case two. So if you ever want to remember which case is possible to have two triangles, just remember it's the ass case, right? I guarantee you'll remember that. The ass case gives you potentially two, one, or no triangles. So let's go ahead and get to some examples. All right, let's go ahead and do an example. We're going to solve this triangle. And just a reminder, what it means to solve a triangle is just to find the length of all three sides and to find the value of all three angles, right? So for this example, we're going to find these two missing sides and this one missing angle. I am using a TI-84. You will need a calculator of some kind for these kind of problems. I'm using a TI-84. If you're using something like this, just make sure you have it set to degree mode. I'm going to go ahead and check. All right, we're good to go. All right, so I'm going to get started with solving this triangle. So the first thing I notice is that I'm given two angles. So anytime I have two angles, I always just, the first thing I do is find this third angle, just because it's real easy to do. So 180 minus 95 minus 45, right? That's how I find this missing angle, because all three of these angles have to add up to 180. So 180 minus 95 minus 45, that's what? Let's see. I think that's 40 degrees. 40 degrees. So that missing angle is 40 degrees. And in this example, we were actually shown a triangle as an image. In future examples I'll just list out the letters, right? And you'll have to draw the triangle yourself. So it depends. You'll see different kinds of examples. Sometimes they'll give you a diagram, they'll give you a picture like I give you here. Sometimes they'll just list side A equals this, side C equals this, right? They'll just list them out and you'll have to draw your own triangle. So I will mix it up. I'll show both examples. For this, we're given it, which is nice, but we do kind of need to name these sides as well as these angles. So it doesn't really matter what I call what. I just have to make sure that if this is angle A, then this needs to be side A, right? So let's go ahead and call this angle A then. I have A equals 95 degrees, then this is side A. Then if this is angle B, then I have this is side B, and then if this is angle C, then I have this is side C. So I'm trying to find side B and side C. So I'm going to go ahead and see if I can use the law of sines. First thing I notice is that I have this angle and I have the value of the side length basically across from that angle. So I know that I have one ratio that I can use. So I know that sine 95 degrees over 5, right? This is like sine A over A. I can use this to solve for B or C. So I'm going to go ahead and use it to solve for B. It doesn't really matter which one right now. I need them both, but I'm going to start with solving for B. So I have this equals sine of 45 over B. Now what I can do is I can basically cross multiply and isolate B. Another trick, and I'll only show this once, I don't want to take up a ton of time. This video is already going to be really long, but there is a trick where basically if I have two fractions like this that equal each other, I can flip both of them and it's still a true statement. So if I want to flip them both, then all I have to do is multiply both sides by sine of 45. That works as well. Or if you want to cross multiply, however you want to do it. This isn't a video on algebra, it's on how to solve triangles. So I'm going to solve for the B, and I end up with, let's see, B times sine 95 degrees equals 5 times sine 45 degrees. So then I'm going to divide both sides by sine 95 degrees, and that's what I'm going to punch in the calculator, this value here, because when I divide both sides by sine 95 degrees, I get B by itself. B equals 5 times sine 45 over sine 95. So let's see if I can punch this in. 5 times sine 45 divided by sine 95, whablam, 3.55. So I have 3.55 for B. And by the way, this is a good trick to check your answer. The order of the angles, so my biggest angle is the side across from that is always the biggest side length, right? And it goes in order. Since this is my smallest angle, this side C is going to be my smallest side length. So if I got something like 7 here, I would immediately know that that's wrong and I need to go back and check my work. So that's a good little trick just to, be more confident in your answer. Is okay, I expected it to be less than 5, so we're good to go there. All right, to find this third side, be careful. Do not use Pythagorean theorem. That only works with right triangles. Unfortunately, we have to use law of sines again. So I'm going to go ahead and erase this work. Erase this, and we're going to use law of sines again. I'm going to use that same sine 95 over 5. Sine 95 degrees over 5 equals... Let's see, so now I want to get this C, so I got to use the angle across from side C, which is angle C. So sine 40 degrees equals, not equals, over C. So now, I kind of do this in my head a lot, but I don't want to skip a bunch of steps, but I do C 95, 540, divide both sides by sine 95. You can kind of, when you get practice with this, you can do it in your head, and you get to C equals 5 times sine 40 degrees over sine 95. All right, so if I punch this in a calculator, what do I get? Let's find out. 5 times sine 40 divided by sine 95. That gives me 3.23, and I am rounding to 2 decimal places, so 3.23, which is to be expected, right? Because we expected it to be slightly less than B, because we have 45 degrees here and 40 degrees here, so just a little bit less than B is what we expected. So we have now solved this triangle. We have all 3 angles and all 3 side lengths. All right, so for that first example, we were actually shown a triangle, right? We were given a picture to look at. We usually won't be that lucky. We'll usually be given something like this, where we're just given 2 angles and a side, or 2 sides and an angle, and we'll have to draw the triangle ourselves. So I want to make sure everybody gets practice doing this. As we can see, this is another case 1 example. Our first example was case 1. This is as well, where we're given 2 angles and 1 side. Okay, so let's go ahead and draw this triangle. And again, this does not have to be perfect. I'm not an artist here. Just drawing a triangle. This is terrible. Oh well. I'm sticking with it. This is A. So this is 70 degrees. Alright? Then this is what? B. This is 60 degrees. Does it matter where I put A and B? No. I could have put A here and B here. What do I have to make sure I do? If this is B, then this is side B. If this is A, then this is side A. If this is C, I don't know angle C, but I know side C. This is 4. Okay? So now what's the first thing I do? Same thing I did in the last example. Anytime I'm given 2 angles, I immediately find that third angle. So this is going to be what? This is 60 plus 70. That's what? 130. So I have 180 minus 130. Minus 130 equals 50, right? You probably could have done that in your head. 50 degrees. All right, so now what? Well, now I can start using the law of sines, and I can find A or B here. It doesn't matter. So let's see. I'll go ahead and start with, it doesn't matter. I'll start with A. So I know, what do I have? I have 50 degrees, and I have the side length across from 50. So I'm going to use that. I'm going to use that sine 50 degrees over 4 equals sine of what? Let's see. I'll find A. So sine of 70 degrees over A. So now I can solve for A and punch this in a calculator. So when I solve for A, I get A times sine of 50 degrees equals 4 times sine of 70. By the way, this is just cross multiplying. I draw an X here. I do 4 times sine of 70, sine of 50 times A, cross multiplying. Now I can divide both sides by sine 50. Like I said, when you get plenty of practice, when you get really good at this, you can probably do this stuff in your head. So cross, cross, I'm left with A equals 4 times sine 70 divided by sine 50. So 4 times sine 70 divided by sine 50, that gives me 4.9. 4.91, I guess, if I'm rounding to 2 decimal places. So what did I solve for? A equals 4.91. Is that what I expect it to be? Well, yeah, it's bigger than 4, right? And I have 70 here, I have 50 here. So what would I expect B to be? Well, somewhere between 4 and 4.91, right? Because across from 4.91, I have 70 degrees, and across from 4, I have 50 degrees. Here I have 60 degrees. Since this angle measure is between 50 and 70, this side length will be between 4 and 4.91. So that's a pretty, I don't know, I think that's pretty cool to notice. I don't know. Okay, so let's go into erase. Let's do one more law of sines and find this last side length. So I have sine 70. Let's see. Sine, well, I don't like that number. I'll use sine 50 over 4 again. Sine 50 degrees over 4 equals what? Now I need to do sine 60 over B. Sine 60 degrees over B. I can solve for B. I'm going to do this in one step this time. I have B equals 4 times sine of 60 degrees over sine of 50. Sorry, I got... I second-guessed myself for a second there. Be careful doing stuff in your head. Double check. Okay, so if I punch this in a calculator, I'll get B. 4 times sine of 60 divided by sine of 50. What do I get? 4.52, which is what I would expect, right? Somewhere between 4 and 4.91. So B equals 4.52, and I have solved this triangle. So hopefully this video helps. I will probably break it up into 2 parts. So the next part, I will do that case 2 because I really want to spend a lot of time on that. That is by far the most confusing part of solving triangles in general, is that case 2 where we can have 0, 1, or 2 triangles. So I want to do a full video on that and do plenty of examples because that's where students tend to struggle the most and need the most practice in that. So hopefully this video helped. If it did, make sure to hit thumbs up. Make sure to subscribe. Stay tuned for more videos and keep flexing those brain muscles. I'll see you in the next video.